So uh, still students are joining. So please ask them to join. So good afternoon to all of you. Shall we get started? Let me share my screen. All right. So I have this here. Okay. So shall we get started then? Right. So I think last time I started talking about this example, right? So we basically started from here and discuss about the simulations, right? So we identify the concept of the simulations and then using our concept of the random numbers, right? So we can approximate certain things. So one of the applications we identified, it's based on the approximation of the value of pi, and so we uh, identify that by drawing the random numbers inside square and then finding out the numbers that are inside the circle, and that will allow us to identify uh, the approximations uh, for the value of pi, right? So we look at that concept last time, and then we went into the applications of that our the simulations concept into we applying that into in terms of uh, our queuing theory, right? So that's once you are looking at the how to describe the behavior of a queue, right? So in that case, we can apply that in terms of by looking at the different situations in queue, right? So that's one of the applications we can discuss there, right? So in terms of the application, the deciding the behavior of the queue. So we went through this example last time, and so that's basically now in terms of the arrivals into the our the particular place. So that's in this case it is the doctor's office, right? So the arrivals are happening with a distribution like this, right? And these are very simple distributions. We are describing the situation, right? So the the arrivals happening in a distribution like this, and then you can find out the cumulative distribution there, and then the service of the doctor is going through a distribution like this, right? And then cumulative distribution you can find out in this way, right? and and then of course now in this example we discussed that the service the provided by the nurse is fixed value, right? So we are not making it random, right? So we just identify this as a random number, the fixed number like that, and then we identify the behavior of the queue. So basically now we identify the interarrival times, and based on these interarrival times, so that's directly coming from the our random numbers we are generating over here. And then we are accumulating the our arrival time. And so we are adding that inter-arrival time into the arrival time, right? And then based on that, we can decide the starting time of each customer, right? So that's initially it is the first customer's the arrival time, and then second one, it has to be the either the whatever the maximum of the arrival time or the finish time of the the previous customer. So that's we identified that. And then the finish time we can identify as the summation of the service time and the start time, right? And then we can decide the waiting. If there is a waiting at the nurse, that we can identify by the taking the difference between the start and the finish. So we take the differences like that, right? And then for the doctor's starting time, right, we can identify that's basically the finish time of the at the nurse, and then the next the starting time you can identify either it is the finishing time of the previous customer or and the um, that's the finish time of the nurse is the arrival time, and then the maximum of the either these two, right? So finish time of the previous customer or starting time of the at the end of the nurse, right? So that's what is the maximum of those two we can identify, and then from there we can find out the waiting time at the nurse, the waiting time at the queue or the doctor's office, right? And then so then from that we can identify overall waiting times, and then we can calculate the time in the system by taking the finish time here and the arrival time here. So the difference of those two will be the time they are spending in the system, right? So like that, now we can simulate that for any number of runs. So I did it for the 100 times here. So you can do it for a larger number of times, right? And then what we can have is the average time in the system, average waiting time at the nurse, and average waiting time at the doctor. So we can calculate these figures and identify the behavior of this queue, right? So what's going on in this queue, right? So by doing these calculations, so the average waiting time at the nurse. So basically, so you have to the wait around the 3 minutes. So always, whenever the person comes into the doctor's office, so they can see that like the average, they have to wait around 3 minutes there, right? And then uh, after finishing the work at the nurse, then you have to wait around 4 minutes, 45 minutes to they see the doctor, right? And then altogether, average time you're going to spend in the system is around 22 minutes, right? So this is now out of the 100 simulations, right? So if you increase the number of simulations, then this number will change, right? So that you can identify by pressing I think it is the F9, right? So by pressing the F9, you can see this is refreshing almost, right? So you can see this number is changing, right? So now this is kind of like having high variability because we are doing only 100 simulations. So you can increase this up to maybe like 1,000 or 10,000 simulations, then you're getting better numbers than this, right? So I let you work on that, right? So now I'm not going to do like larger number of simulations here because um, my computer will stop on, so that's why I don't want to do a larger number of simulations here, right? So that's the idea that we discussed last time, and then I want to do some changes here. So I like to have some variability for this service time at the nurse as well. So I created this one here, right? So I basically like modified the question and I add the service time for the nurse and some distribution for that as well. So basically now I created this distribution here, right? So given that 2 minutes, 4 minutes, and 6 minutes with these probabilities, right? And then I have the cumulative distribution there. And then I generated that third random number for the nurse the office, right? And then the service time, I can look at this distribution here, right? So then I can see I have the random service times here, right? And based on that, I can calculate that the finishing time as before, right? So these are all the same as the previous one, right? Everything else is same as the previous one. Only this adding the random number here and then service time is the new thing here. And then you can see the calculations. So, and then the waiting times you can calculate and timing the system. And then you can see the average values are going to be like that. Now what happens is that now with my new distribution, you can see it is 2, 4, and 6, right? So therefore, like the previous it was 7. So it is kind of like getting smaller here, right? So this I'm changing these numbers to be much smaller. So that means my average in the timing system and average waiting time at the nurse, these two are going to reduce. So you can see it is much smaller than the previous one, right? And if you even press F9 here, so you can see it is getting much smaller numbers compared to the previous one, right? So that makes sense, right? So this is kind of like a much smaller the numbers than the previous one. So that's like the modification we can think of like in the queuing system like this. So and so it allows you to find out the various calculations like that. So that's the one of the examples we can have in terms of the queuing models, and then the in terms of the simulations, we can have the few more applications of the simulations. So this is another application we can have in terms of the simulations. So let's you think about this one. So this is kind of like looking at that behavior of a certain situation, and then based on that, the we can simulate the situation and calculate some average the value for the situation. So let's we think about the applying that our simulation concept and the looking at some probability there, right? So let's think about this example. Uh, so that the automobile production, right? So they have that they usually create 100 cars per day, right? But actually, when they say that they are producing 100 cars per day, but that's a random variable, right? So you can see that so their production is kind of like deviating from 95 to 105, right? So with the probabilities given like that. So that's the probability distribution of the situation. So you can see that like now, just like our previous example, that this distribution is kind of like much the complicated than the previous one, right? But then like even you can use some common distributions on these cases as well, right? So anyway, like so we can use whatever the distribution is available there, right? So and then what we want is the cumulative values here, and so that's the cumulative distribution we have there, right? So the and then if you read the rest of the question here, so the, so that is the distribution is given here. And then the finished cars are transported across the bay, danger of each day by a ferry, right? And then the capacity of the ferry is 101. So if you have like one additional car, right, so you can the transport it, right? The the so I think this is ferry capacity has to be 101. The uh, so we have the ferry capacity as the 101, right? So it's like the so this will take some time to refresh actually, right? So uh, the and then the and then now we want to find out and then what will be the average number of cars waiting to be shipped, and then the what will be the average number of the empty space on the ship, right? So it's like so whether that uh, some of the cars are waiting or there can be like the ship is running with empty spaces, right? So that on average what will be that situation. So like now this is kind of like we can find out some average number for that, right? Our target is to find out some average number for these the figures, right? So now we can simulate that our situation. So now I like to simulate it. Maybe we can go it with the say I did it for the 30 days, right? Or we can do it for 100 days or whatever, right? So we can decide to initially simulate it for a certain number of days, right? So let's see that how we can simulate it. So we need to generate the random number, right? And then I can go with that the having that numbers from 1 to 30 there, right? So now, in general, of course, now I can write that uh, two numbers here and then drag it down until that 30 or like there are like in terms of if I want to show you that some options that are available in the in Excel, right? So I can go to this home tab, right? And then that right below the summation mark here, right? So we have this filling one here, right? So that's I can click that one. So I can fill down or fill up and so on, fill left and so on, right? So we have that the some options there, and there I have the uh, series. So I can fill it as a series in terms of the columns, right? And then I want to increase the by step value of 1, right? So you can change the step value to be 2, 3 or 0.5 or 0.25 whatever, and so we have different options there. And then I had to give the stop value, so I go for the here that up to the 30, right? So therefore I can give it as the 30 there, right? So I can fill out it 30 and say okay, and then this will increase up to the 30, right? So since I have already done it, I will not say okay here, right? But so that's how if I want to have it like a larger number of times, then we can use this option here, right? So I'm going to use this later as well, right? So that's I'm just telling you that you can generate that and for simulations here I can see I go from say for a larger number of times I go for like 5,000 times here, right? So so that in that case, dragging down up to 5,000 is kind of like uh, difficult, and so therefore we can use that series command there, right? So so those are like some other options we can have. So I generate the 30 days here, right? And I just have the random number there, and we can use that truncate function as well. And I didn't use it in here, just I use the rand function, right? So then it is generating random number between 0 and 1 that I can use as a probability presentation for this probability, right? And then I want to decide that what is the exact value I can get from here, right? So based on the probability value, and I'm checking that this cumulative probability, right? And I'm checking whether this one is belong to any of these categories here, right? So then if I think that like 0.455, so that's going to belong to this category here, right? So mm, correct here. Okay. Mm. Something might be not correct here, right? So that's they're looking at that and okay, so this is 0.06. Yeah, that is in here, right? So it's uh, above this number. Oh, okay. So they are taking it as the it is above that number, right? So it is so therefore they are picking that number as 100, right? So it's between these two, right? So should correct. That's 0.5. Okay. So these are the lower bounds, right? So these are the lower bounds. So that's okay, right? So therefore it is above this number and below this number. So therefore it is belong to that category, right? So that's okay, right? So this is the above 0.45, but this means above zero point 0.4 and below zero point 0.6. So that's correct, right? So therefore it is going to be the 100, right? So we are identifying that category there. And it's the, we are checking whether it is above certain number and below that one. So it means between them, then we are picking that number there, right? So looking up is indicating that check this number there, right? So then you can see, so that's how we can identify the capacity there, right? The production capacity. So these are the indication of for each day and different number of productions, and then based on that we can see the number of cars waiting there. So until that 101, right? So nothing is waiting there, right? And then the if it is 102, then it's waiting one, right? So 104 it is waiting three. So we can take that as the taking the difference between our production value and the maximum capacity 101, right? And the difference of those two, and if it is the difference is negative number, we put as the zero, and maximum of right? So that's how we get the zero there, right? So and if the difference is a positive number, you get that number. So like that, we can see uh, the average. So on the for each day capacity of the cars are waiting, and then take the average of that, and then the opposite of that is the empty spaces, right? So if you are having that production of 100, and then there will be one empty space, and if the production is 99, then there will be the two empty spaces. So we can find out the difference between the production and then the ferry capacity, right? So that's from difference from ferry capacity to production. And then if it is a negative number, we put the zero. So then that's if it is we are producing more than the capacity, then no empty spaces. Empty space is zero. So then you can see the average of that. And then now we can identify as we did a simulation for 30 days, right? So that's considered as a one the replication or one simulation. And so we can identify the average from there, and we can identify that as the one simulation. So that's we can identify as a one simulation, and then we can take those two numbers as their averages, the averages of the cars waiting and average empty spaces. Right, so we can identify those two numbers there. And then what we can do is that we can repeat this one uh, for a very large number of times. So usually, I think in Excel you can go up to 10,000 or even beyond that, right? So, but in here I did it only for 5,000 here, right? So that's again now due to the capacity issue in my computer, right? So if I go for 10,000, then it's kind of like my computer might get stuck. But you can try it, right? You can try it, even more than 10,000, right? Depending on that, whatever the largest number that is provided in your Excel, the package that you have, right? So you can go up to the larger number of simulations like that. So now let's see how we can do this, right? So I just copy and paste these two numbers there, right? And then if you look at this here, right, I'm using some command like that, right? So how this command comes in, right? So let me show you that, right? So now again, to run these simulations here, right? So I can go to the home and this series here, right? And then I can put 5,000 here and increasing by one, and then I have to make sure that it is in the column, right? And the type is linear, right? Then we can press OK, and then this will go up to the 5,000, right? So since I have done it already, I'm not going to do it again. And then to get these numbers here, right? So what I want to do is, so I can go to this data package here, right? So let me just type it, right? So give you some note down here, right? So first I will say that, so to get the series, right? Go to the home, and then the field package, right? So then uh, so to get the simulation, go to the data package, right? The so so you can go to this data function here, and then what if analysis and data table, right? So, right, so, and data table. Okay, so just you can go to the the what if analysis there, right, and then data table, and then now we can select that filling the rows or filling the columns. So now since we are filling the columns, right, so we have to use the column input, right? Now what we do is like now we are not giving any input value, but just we need to select some cell for here, right? So what I will do is like I can select any empty cell there, and so you can select any empty cell. It doesn't matter, right? So the you can select any empty cell there, right? And make sure that it's for the column, right? And then say okay, right? So then it is automatically filling out that. Okay, so I will just cancel this, right? But then in general, that's what you have to do. So then you can see table of 5, this is going to be appeared. So same thing I had to do over here as well. So I can generate that both of these columns 5,000 times, right? So by the using that particular command, right? So then once I have that like this as a table, and so then you can easily get that one. So it is already generated 500 times, sorry, 5,000 times. Now after doing the calculations, then you can take the average of each of the two columns. And that will tell us in general the number of cars waiting and the number of empty spaces. So by looking at these two numbers, what can we see? Now in general with this particular distribution, so on average it is the kind of like we are waiting only for around 0.5 of number of cars. So that means like in general, so we don't have to wait too much. And so like in terms of the cars, right, it's only like half of the car, right? So that means not regularly too many cars going to be waiting, right? But then in terms of the empty spaces there, so you can see that the around 1.5 empty spaces are there. So there will be like slight the empty space there, right? So so that is indicating that like the so the, in terms of the empty space, we may have freedom like chance to improve, right? So so that means like uh, maybe like we can increase the production capacity, right? So that we might avoiding that too many cars are uh, in the under the too many empty spaces may not be there and so on, and so we have that some freedom on modifying them. So that's how we can interpret this. So these are the kind of like we did the uh, 100 simulations initially, sorry, 30 simulations, right? And then take the average, and then we repeat that concept for 5,000 times. I did it for 5,000 times. So these are the averages out of the 5,000 times. So that's kind of like indicating the overall the setup is kind of okay. And because in terms of waiting cars, it's something below one, right? So that's in general that the space is enough. And then like in terms of the empty spaces, it's kind of like just one empty space might be there. So then like maybe initially you have the capacity as the 101, right? So maybe you can drop down to 100, or capacity you can drop down to the 99 or something like that, right? So that you have freedom to change that as well. Right now, if I change this to the 100 here, so then you can notice that now you can notice that, so this increases to 0.6 and this goes to 1.3. So that slight change is there, right? So like that, you can try some different things there, right? And see any particular differences you have there. So that's how we can work on that our the concept of the simulations, right? So there are like we can do several examples, right? So similar to this one and similar to the previous one, right? So due to the time constraint, of course, I'm not going to spend too much time on these calculations, right? So I'll just introduce you that some of these methods there, and in terms of like given theory also there are like various other applications we can talk about, right? So I just talk about one example there. Okay. So that's the basically the idea of how we can perform this. And then I'd like to go into our next topic right now. And in terms of that, the rest of the classes we are having, right? So I noticed that this is our last class, right? This is one before the last one, right? So we have one more class the next week, right? So then, of course, uh, the, so the next so we can have the next week we can have one class, and then uh, I'd like to do some the revision before the exam as well. Do you have any idea when you have the exam? Do you guys have any idea or not yet? Is the exams are finalized? Anybody there? Hello, hello. You guys are not there. Any idea about like when you have the exam? So what I want to do is like I can take the next lecture and discuss about that. I have like two more topics to discuss. Right? So then like I can take one extra lecture, maybe like some weekday afternoon. So that means like, so today is the 14th, right? So we have another lecture on 21st, right? So somewhere like around 25th, I like to have a extra lecture and I can discuss some revision for the final exam. So, uh, are you guys there? Like any comment on that?
It's starting from 15th March, sir.
Our exam is on 15th March. Okay. So we have time, right? So are you guys okay to do like, so I will do the lecture on today and then like on 21st, right? So we can have the two lectures there and then like revision on 25th. Will it be okay? I can arrange a lecture on 25th, I mean, like at night, right? So something like starting from maybe like 6 or 7 and like around 2 to 3 hours, something like 6 to 8 or six, like 6 to 9 or something like that, or 7 to 9, 7 to 10, something like. So please check with other students, right? And next time tell me like what time suitable or like is it okay, right? So please check with other students as well, right? So and like maybe like end of the lecture today, right? You can if you can check that and inform me, right? I can arrange it, right? So I can do a lecture on 25th, something like starting from 6 or 7. Tell me what is suitable time for you guys as well, right? So so please we will arrange it, right? So let's try to arrange like that, and so I can do the revision or like since now you said that it is on March 15th, right? The exam is on March 15th, and so it's kind of like 1 month, right? So even now, if you don't like to have it on 25th, I can do it later as well, like, as you have the exam, right? Something like on March 4th or like February 28th, something like that, right? Sorry, no, the March 4th is 25th, right? So week after that is the March 4th, right? So we can do it whatever it is, right? So we can do it like on March 4th or 11th, right? So we have those 2 days as well. If you like, I can do on any Wednesday, I can do, right? So Wednesday afternoon, I can do a lecture, right? So let me know after this, end of this class, right? So you can let me know. So, right. Uh, so, hope that is okay, right? So now that is the, uh, with that, then I can discuss that this so I can finish up this discussion on the simulations, right? And if you have time, I can do one or two more examples from this as well, right? And and then I can go into the our next topic. So that is the optimization topic, right? So first I need to give you some introduction to this area, and then I can do like I plan to go for like several examples like this, right? So we'll see how many examples we can do, right? So this is kind of like another huge area, right? So we can discuss various applications regarding this area, right? So let me first introduce you this the concept, right? Give me. Shall I take like 10 minute break, and then I will start around at 2 o'clock. So shall I? So let's take a small break, and we will start at around 2 o'clock. I will start at 2 o'clock. And in the meantime, I will provide you the attendance. You can mark attendance. So you guys can mark attendance, right? And then also like the uh, if you check that like both of those Excel files are available in the uh, we go to the notes here, right? So both of those Excel files are available there. So you can download the simulations, right? The you can go for the simulation file here and then the optimization file here, right? So those two are available, and so please mark your attendance. Okay. Sorry about late entry. So, uh, shall we get started? Right. So, let me know. Right. Okay. So let's start discussing on this topic here. So that is the so we have this optimization, or we can define it as the linear program. So that is the so under the this linear programming or optimization. So our target is to find out that uh, a maximum value or minimum value. So we are trying to do some maximization or minimization. So in general, that's why we call it as the optimization, right? So what we are trying to do is that now, in terms of like, if you think about the practical situation, so if you are doing some production, or if you are looking into some kind of like the practical situation where you have some resources, so various type of resources are available and so on. And if you think about various the situations like that, then in general, what happens is that when you think about the various situations, so our target is to maximize our profit or minimize the cost. And so we are basically thinking about a situation like that, right? Then uh, practically what happens is that now we cannot keep on maximizing the profit because there are some limitations. So due to various other factors which are limited. So therefore, when you are trying to maximize, right? So there will be some limitations. So we like to see that based on those limitations, right? What combination will give us the maximum profit? So we can see various the limitations can be there. So now, if you think about in terms of like two variables, right? So then we can basically uh, identify the situation in terms of the graph as well, right? So we will first identify the situation in graphically as well, and then it will give you some idea like how we can maximize or minimize the situation, right? So and then, of course, the after that we can think of like going into the higher order situations, right? They will have the larger number of variables available there. In that case, of course, graphically we cannot see that situation, but we can use our software. So in Excel, we have that particular software called the solver package. So we can use that package to answer those situations, right? So let's quickly look at that. I will show you how to get the solver and so on, right? Now, before going into that, let's look at this example here. So we have a particular example given like that. So let's read down this example. So we are looking at that small factory. So their production basically restricted to the uh, two types, tables and chairs, right? So they're like, now you can see that there can be the various types of variables that are available, right? So so then we can see that like now in terms of the tables and chairs, so now the two variables that we are going to define, right? So I can take X as the number of tables and Y as the number of chairs. Right? So we can identify the tables and chairs as the X and Y. So that's the number of the tables and chairs we are going to produce. Right? So we can think of those two as they were two variables, right? So these are the two variables we have, right? And then in terms of that, the two variables, so we can identify that uh, profit from one table, right? So once you produce the table and you sell it, right? So you get a $40 as a profit, right? And then profit by selling a chair is 30, right? So we can identify profits, right? So from tables and chairs, which is going to be 40 and this is going to be 30. So that is indicating that without producing the chairs, if you keep on producing the tables, that might be more profitable, right? So that's initially that's what we can identify, right? But then due to our limitations in terms of their resources, right? So based on our resources, we can see that the it may not be that in terms of the producing that always tables may not be the perfect combination. We might have to produce some chairs as well. So due to our resource availability. So in terms of the resources, right? So we are going to use now, of course, now to produce the uh, tables and chairs. Of course, we need that. Mainly our resources are going to be wood and then the labor, right? So how many people working at our place, and then the in terms of wood, right? How many wood pieces available at our place, right? So and when a particular production run or whatever, right? So that is the uh, now in terms of that. So we are thinking of like we are producing only one type of a table and one type of a chair and so on. And so that's to produce each table, we need 2 units of wood and 1 unit of labor, right? So therefore, like you can see, in terms of the requirements for resources, the in terms of the resources, we can see the tables, right? So we have the wood and labor, right? So, so in terms of the resources, uh, each table requires 2 units of wood and 1 unit of labor, right? So for the tables, this is 2 and this is 1, right? And then the uh, each chair requires 1 unit of wood and 1 unit of labor. 1 unit of labor, right? So that's the in terms of each the uh, table and chair, right? The resource that require, right? So that to produce them, right? So uh, and then the total capacity availability is going to be 100 units of wood and 80 units of labor, right? So now we are measuring that. Like maybe like for a particular day or for a particular week or whatever, right? So these are the total available units, right? So that means like 1 person hours or like So we can define these units in terms of whatever the measurements that we are having, right? So it's maybe like person hours or whatever, right? So therefore, altogether, the in terms of wood, the total resource availability is 100 here, and that's what we have, right? And then we need uh, 80 units of labor, and so it's 80. So that's the our total availability we have, right? And then X and Y, we can present them as the number of the chairs, tables, and the chairs, right? So X and Y, right? So that's what we have there, right? So then, uh, so if I produce X number of tables and Y number of chairs, what is going to be my total profit? So I can measure my total profit here, right? So by taking the X number of tables and Y number of chairs that we are producing, right? So the total profit I can define as the 3 equals 80 times X plus 30 times Y, right? So if you produce both items, right? If you just produce the tables, then it is this is it's given by 0, right? And vice versa, right? So you can define that how many tables and how many chairs you can produce, right? So now the in general, of course, now to maximize our profit, right? So we want to maximize this profit, right? So we want to have the maximum of this profit. Now as long as you are producing say 100 or 200 or 300 and 400, so if you keep on producing the items, then our profit will always going to be the maximum, and it's keep on increasing, right? But we know that we have some limitation. So the, now in terms of that production, right? So we cannot produce now. If you think about just producing the tables, right? So if you produce like 50 tables, then entire wood is gone, right? So because now the 2 times 50 is 100, right? So therefore, if you are just producing the tables, that gives us only the to produce the 50 tables. But then you can see that once you produce the 50 tables, then in terms of labor, there was whatever actually we are used only 50 of them, but we have 80 of them, but so that 30 is kind of like wasted, right? So we are not using them, right? So so therefore, like if you're just producing the tables only, then there's kind of like a disadvantage on that. And on the other hand, if you just produce the chairs, what happens? Then, since the labor hours are 80 available, then if you are producing the chairs, then you should have you cannot produce that 100 chairs because only 80 the labor hours are available. So therefore, you can produce only 80. So then, in terms of that wood, you are missing like 20 units of wood are just again wasting, right? So that's you're not going to use them, right? So like that now you can see that those two extreme cases, we're just producing the tables, we're just producing the chairs, may not be the most appropriate option that we can have. So other than that, we can find out that something in the middle might be suitable. Right. So that's why we need to do this, the linear programming or the optimization. Right. So the linear optimization, these are called the linear, right? So all these are linear applications, and you can see non-linear applications later. And so I think we don't have time to go into the non-linear cases. right? So that's the idea of that all these are there are linear options that we have, right? So now that indicates, and so we have that we cannot keep on producing them. There is a restriction. So if you think about in terms of wood, right? So what is the restriction that you can have? So if you're producing X amount of chairs, then altogether 2 times X amount of wood that we need, and then Y plus Y amount of wood we need for the chairs, right? So therefore, altogether I can define them as my constraints, right? So these are my constraints. The so these are the restrictions we have, right? The constraints. So we have that 2 times X plus Y, that is in terms of wood, right? So 2 times X plus Y, that is the total amount of wood that we are using. That has to be less than or equal to 100, right? So that is the restriction we have. And then the second restriction in terms of labor, it is the X plus Y. So 1 times X and 1 times Y has to be less than or equal to 80. So these are the our two restrictions that we have, right? And then other than that, of course, we know that altogether the both X and Y are positive, right? So they has to be greater than or equal to 0, right? So those are the like you can see the our equations are given there, right? So we can identify our entire problem. We can have it in the terms of the our the if you uh, put them into the mathematical formula. So this is our formula that we can define in terms of the mathematical application. So that's we call it as the formulation of our problem, right? So I can formulate my problem like this. Okay. So once I formulate that problem, then I can try to solve this one. Now first, I like to show you that how we can tackle this one using the graphical technique, right? So now since I have two variables X and Y, right, I can graph it, right? I will take here to graph it. So I can define X and Y axis here, right? So the X and Y, I know that like now the maximum that X can go is up to 50, right? And Y maximum is 80. And so that we know that we have those two restrictions there, right? So can go up to 50 here and can go up to 80 here, right? So that we know that those two restrictions are there, right? And then altogether, right? So that I have this function here, right? So that is the our requirement we can have there, right? So in terms of the profits, right? But before that, I like to look at the our two constraints here, right? So if you look at these two constraints, right? Now I can draw some lines here representing these constraints. So let's take the first one here, right? So this is the line. Uh, Give me a second. Okay, right. So, right. So now, if you try to uh, look at these the two constraints now in the two dimension. So these two are representing two lines, and if you take the equal sign, of course, right, and the less than sign is indicating some area. So we'll try to identify what is this area, right? So let's try to identify this area. So now by taking that each of these constraints, right, I can take this one first, right? So if I take x equals 0, right? If I put x equals 0, then y will become 100, right? And if I take y equals 0, then x is equal to 50. So we can identify these 2 points here, right? So these 2 points are like this. Uh, x is 0 and y is 100, right? So I can take somewhere here and take 100 here, right? So that is, I have this point here, right? And then y is 0 and x is 50. So I have this line here. So I can draw this line here. I can draw that line like that. Okay. And then I can see that less than sign here. So it is indicating that if I take the 0 point here and so that is below 100, right? 0 here, right? So it is below 100. So that means I'm talking about this area here, right? It's anything below this line, right? So we are talking about that region. And then if I take this one here, and I can put x equals 0, and then y is 80, and when y equals 0, x equals 80, right? So we can identify the 2 points like that. So, and the, so that means x equals 0, y is 80, that is here, and then y equals 0, x is 80. So I can put 80 here, right? I can take some point like that. And then I can draw this line here. So I can draw that line like that. And then again, if I take the 0, then this side is the lower side, right? So I can draw this region here. Okay, so I can identify that these two constraints are basically identifying some region, and then I can see that this particular area is something common, right? So you can take this intersection point, and this region is something that is common, and then we have these two here, right? So both x and y are positive, so that means we are only considering this region here, and so I can draw the lines say like that. So I'm considering this particular region like that, right? So then I have to do this entire optimization in this particular region. I cannot go beyond that then, because if I go beyond, then I'm violating these two constraints, and I have to do the maximization. So then I can see that like I can find one maximum over here and one maximum over here, and then other maximums over here, right? So we can identify several maximums like that. Okay. And then of course, now the idea of that maximizing it means that so we can take this point here, this equation here, right? So by taking that, now it is, I'm saying it is equal to z, right? So but if I take this is equal to some constant, right? So I can take that equal to some constant there, right? So then I can draw this line as well. right? So of course now this constant we have to find out some value there, right? So based on that, I can draw this line as well. So if I draw this line, so now I'm not going to draw it into the scale, but I can draw that line. So it is something goes like that, right? So some line goes like that. So that means now I can move that line up and down throughout this region like that, right? So once you are moving that line throughout this region, right? So the theoretically we can find out that, right? The so the maximum point will become the last point that this line will leave the region, right? So if you keep on moving this line like that, right, then you can notice that once you come to this point here, right, once you move that line, right, so any line like this, right, so you can see once you move it, right, so the last point you are leaving the region is this particular point here. So it turns out we can find out that the maximum point is this guy, right? Or you can solve these two equations and find out that point actually, right? But so if you do it manually, of course, you can find out it. So I am not going to ask you to do this manually, right? Just so I'm telling you that this is the background behind it, right? So I just want to show you that theoretically this is what happening, right? So and then what happens is that people have developed some mathematical formulas for this, and that's called the simplex method, and different approaches are there, right? So, but then theoretically, we can see that, like, so if you find out that some region like that, then once you move this line here, that in terms of the constraint as an objective function, this is called our objective function, right? So that we have a profit equation, right? So if you move that, then last point it leaves the region will be the optimum point. So now for this case, you can see if you move it, then this is the point you're going to leave, right? So that's our optimum point. Okay, so we can identify that, and so by solving these two equations here, you can find out that if I just take that these two equations and if I subtract them, then it is going to give you the x equals 20, right? So it becomes 20 and then y becomes 60, right? So that just solving these two equations, you can find out that. So this is the x is 20 here and y is 60. So that's the our maximum point we can have 20 and 60. So that means like the maximum profit we can get by producing 20 tables and 60 chairs, right? So that's the limit that we can have, and then maximum profit we can have is this. So that is 40 times 20 plus 30 times 60. So 260, right? So that is the maximum profit is $260, right? So that is the maximum profit, right? And you can see that like now, if you take these 2 points here, so if you just produce the tables, then it is 40 times 50, so that is 200, right? So it's below that number. And if you just produce a chairs, it is 80. And then the 80 times the 30, right? So that is 240, right? So that's even below, right? So that's the 260 is the maximum profit you can get, right? So that's the idea of that in terms of uh, identifying that our optimum solution. The graphically, like now when you have a very simple situation, graphically how you can see that. Okay. So now we will identify that the how we can get this solution using the software, right? So that's the our graphical method, right? Now let's see that how we can use our software to get this solution, right? So let me identify our variables here, right? So now I can first identify the my objective function, the the objective function we can define, right? So in terms of the our variables x and y here, right, I can put them, right? So I leave these two cells to calculate the value of x and value of y, right? And then the our the profits that we are getting from each one, we know that we have these 40 and 30 there, right? And then our constraints, the values that we have in terms of root constraint, we have the two here and one here, and the labor constraint, this is one and one, right? So those are the our the constraints that we can have, and normally like x and y greater than 0, we don't need to put any constraints here. And then each one, the maximum capacity that is available, right? So we have those 180, right? So now you can see that like I have the my objective values, I can keep it over there, right? And then uh, I will take this one cell here and have the less than or equal signs, right? And then I have the maximum capacity availability. This has 100 and this has 80, right? So then, of course, now uh, by using these are the our answer that we are looking at, right? So maybe I can put some color for that one, right? And then I need this one to be calculated as the my objective function. So I can use a different color there, right? And these two as my constraints. I will use those two as my constraints, right? So that's how I can define these cells here, right? So I need first, I need to define these cells, right? And then I can identify my objective function here, right? So that is my maximization we need. So what I'm going to do is I can use this Excel function here as the sum product. So we have this sum product command here, right? So what I want is I can take the summation of these two. So each one multiplied by these two. So that sum product means that 40 times this cell here x plus the 30 times y summation. And so there is summation of the products, right? So it's you can find it. So now initially we put them 0 here, right? So that's why it is 0, right? So by default, the value is 0, right? And then these are the constraints, right? So each constraint I can define as the, again, I can take this sum product, and then I can take the multiplication of these two with these two. And I can take them as the fixed values, right? I can place F4 there. So that is the uh, value, and I can pull this down. So I can get that these two fixed, right? So those are my constraint values, right? The value of each constraint, right? And that is this value has to be less than equal to 100, and this has to be less than equal to 100, right? So now I know you know that the solution is 20 and 60, right? So that's going to give you some numbers that's available there. And so 20 times this one is 40, and then uh, this is 60, so 40 plus 60 is 100, and so it's there. And then this is 20 plus 60, it is 80, right? So it's already both are actually using up to the best, right? So we have those numbers there. In practice, of course, but it's not going to be much simple like that, but we have some nice answer here, right? So this is a very simple example we can have. So now once I define all these cells like that, then I can use this solver package. So we can go to this data, and then you have this solver here. Now it may be not available directly, right? So you can get it into here by using the file and options here, right? So once you go to the Excel options, you can see the add-ins here. So go to the add-ins and check whether that the solver add-in, whether it is here or it is here. So usually it is going to be in the inactive ones. So then you can click whatever that is in the, if it is in the inactive one, and then say go. Then it will go into the active part here, right? So like that, you have like several add-ins here, right? So usually that solver add-in is not automatically here, right? We have to bring it up to here. And so by clicking it and say go, right? So you can do that, and you can make it available there. And then once you go to the data tab here, then solver package will be here. So I will take this one. So then we have that options of maximizing and minimizing. So and then my objective function value here, right? So that is this cell here. So that's the objective function value. So that is what we want to maximize. So we have the different values, right? Maximization and minimization, right? So that is we are using maximization here. And then by changing the variable cells, so that is we are changing these two, right? So that's the objective values that we have, right? And then we can add the constraints here. So by clicking at the here, right? So so this is the cell reference, and that is the less than or equal. So we have options of less than or equal sign, and greater than or equal, and then we have the int, bin, dif as well, right? So I will introduce what are these later, right? So and then the right hand side is this one. So that's my first constraint. And second one. So we basically I have only two constraints, right? So then I can finish that. So I have these two constraints there. So that's how we can set up our problem in terms of the Excel here. So you have to put your objective cells here and then the constraints here. Okay, so and then the solver method here, so that these are some different techniques available, right? So this we can go for the simplex linear programming, right? So that's the one of the methods, and even that this one is fine, right? So we can go for those two, right? But we normally we don't go for the evolutionary, right? So you can go for one of these two, right? So I can just try this one, and then like I don't need to worry about anything else. I can say okay, I can go for the solve, and once they solve it, so you're getting some output like this. And they're asking you to keep the answer and give solution. No, restore the original values. That means 0, 0, right? The and you can report. You can have the different reports and so on. And I will come to this. We don't need to worry too much about this right now. So I want to look at the solution, right? So you can have it like that. So that's basically you can see the answer there, right? So Okay, right. So this I was multiplying that here, right? So it is this is 800 and 1,000. So so it is the 2,600, right? So so that's the 20 and 60 values are there, right? So so that's the indication now in terms of like the other uh, analysis we can think of like now. Usually once you see that like these numbers are there 180 and so on, right? So they might not be exactly getting these numbers equal to this one. They can be something lower than this. So that means we are having some additional resources there, right? So that's indication of that. We can go for those sensitivity analysis and so on, right? So we can think of like what we can do with that additional resources that are left to alone and so on, right? So what we can try about them and so on, right? So we can identify some properties like that. And this is indicating that we are getting the two solutions here. And in this case, of course, we are getting these two solutions as the numbers, right? Complete numbers as integers, right? But normally these two can get any decimal numbers as well. And so there's no any particular restriction that this cannot be in decimal values, right? Now, just to indicate that, I can change one of these. So I can make this to be 45, right? So if I do it as the 45 there, and then like now it is not automatically going to solve it, right? So I have to do it again. So, so I have to go through this one again. So oh, okay. If I change that one, doesn't change anything, right? So, but if I change somewhere here, maybe I can put this as 3 here, right? Now you can see that this constraint is violated, right? So it means this solution may not be the correct one, right? So I can try this again. Okay, so then it is 10 and 70, right? So the changes like that. I will put 2 there. Oh, okay, so then now it becomes 0 and 50. So that means there's no point of producing this one, right? So I may have to change this as well. I can put this as 1.5. No, no, that is still, I can make this to be 1.5. So now you can see that it's 10 and 46.6, right? So they are getting some the different values like that, right? So that is, so that's just I want to show you that now in this calculation. So in general, that is like the we are not putting any restriction that this our solution has to be complete numbers, right? So it can take any real number, right? So there we normally we say that like once you draw this graph like that, we are saying that all these numbers are possible, right? So that's why any real number is possible, right? So that's something you have to be careful on, right? So but practically we know that these two has to be some complete numbers, right? Now in terms of like reducing the chairs, 46.66 chairs is doesn't make sense, right? So that's either it is 46 chairs or 47 chairs, right? So we have to check on that, like we don't need any the decimal points here, right? So that doesn't make much sense. So to avoid that, one option we have is that now I can go into our solver here right? And I can add an additional constraint here. So I can say that my two objective values, I can select them and I can say that they are integers. So that's an additional constraint I am putting and say that they're integers. Okay. So I'm getting some additional constraint like that. And then I can solve it. Now you can see it goes down to the 46. So then you can see these two are kind of like slightly below this one. And so then that's, you can see some modifications you can try here, right? So that's the indication that now we have to make sure that these two has to be the complete numbers, right? So we have to be careful with that, right? So that's how we can work on this the application of this simplex method and the in terms of the our solver package, right? So yeah, the using that solver package, right? So so that's how we can use this our linear programming concept, right? So these are called the linear programming optimizations, and so we are maximizing, right? And same thing you can do with the minimization. So now graphically, if you think about the minimization, then what happens is, so now we have the graph here for the maximization, right? And for the minimization, what we are going to have is the, we can have something goes like this. And we are looking at this region here. So we are looking at this entire region like that, and we can have the objective function and we can move it down. We can minimize it. And then our last point it is leaving. So this is the last point. We are leaving this entire region. So we can find out that will become our objective value. And now, the, now here you can see that like if you have only two constraints, right? So then always going to be the intersection point, right? But there can be more than two constraints as well, right? So that's like you can have that several constraints can be there, right? So there can be like one line goes like that, and the other one might be going like that, and there's another line that might goes like this, and so on, right? So there can be different lines going like that, right? All these are lines, right? So therefore, our region can be, so this point, and here. So that's the region then. So once you include that several constraints there, then this region will become, will be much complicated like that. So then once you're moving your objective function, then you can see it can be living at this point or it might be living at that point, right? So there's kind of like chance of having the two values, one of them becomes optimized, right? So it depends, right? So uh, then we can identify what are the optimum values like that. So so that's the indication like now. Once we keep on adding the constraints, then we are basically the getting much complicated region like that. So it can be like maximizing or minimizing, right? In both cases, you can have much complicated regions like that. Okay. So so that's the idea of like this example here. So let's look at this one then. Let's move on to this example here. So we can see that some the information already here. So let's read this one. So the manufacturer is producing E1, E2, and E3. So they are producing three items here, right? So that's becomes the graphically difficult to find out, right? So it's kind of like three dimension now, right? So if you're looking at the three variables, right? So basically now we have to look at three dimension like that, right? So in three dimension, we are looking at some region like that, right? So yeah, we are looking at some solid region like that. And then the objective function is kind of like a plane here, right? So you're moving that plane up and down like that, right? So some three-dimensional region is there, and then you are moving that objective function as the plane. So that's kind of like graphically difficult to see, right? So that's why we have this the simplex method or whatever that solution technique that we can use here. Right? So let's try to use it in here. So and then regarding the each equipment, right? The E1 requires 4 hours of grinding and 2 hours of polishing and 1 hour of finishing, right? So we have that uh, three things we are looking at in terms of that our the production, right? So we are uh, looking into the grinding, polishing, and finishing, right? So those are the uh, three major things that we have to do in terms of each production, right? So in order to produce that each item, right? So uh, so you need that grinding and then polishing and finishing, right? So it's kind of like maybe like you are producing some ornament or something like that, right? So you need to grind it first and then polish it and then finally finish it by painting or something like that, right? So those are the three things we can need to do. And then like each item, so you are maybe producing like three types of ornaments or whatever, right? So each one, the the I think this is E3, right? So this is X3. So some typing mistake is there, right? Mm, So so we are the and these are the our decisions that we have to make. How many we need to produce from E1 and E2, and then I can define X1, X2, and X3 as the number of items you're producing on each one. And then we want to maximize the profit, right? So let's see that. So we can see that each one, how many units required, right? 4, 2, and 3, 4, the 2, 5, and 3, and so on, right? So we can find out uh, each requirement. So, and profits are given there, right? And before that, like, uh, and grinder is 40 hours, total is 40 per week, and then polisher and finisher works 60 and 50. And so those are the maximums that we have. And so that is the maximum of each one, right? The so 40, 60, and 50, right? So and then the profits are given there. E1 is $3 and E2 is 4 and then E3 is 6.6346. So so then like in terms of like the okay, I was I forgot this part here, right? So that I was checking that why that these are 80 and 180 here, right? So the uh, the manufacturer has two grinders and three polishers and one finisher, right? So therefore, like in terms of grinders, one works at 40 hours and two of them are, that's why it is 80 here. And then uh, the the polisher has like 60 hours, but three of them are there, so it is 180. And then finisher is only one, so that is 50. So that's how these three numbers are there, right? So, and then now there is another restriction here. So these are the three restrictions that we have, right? So then we have that whatever the E2 produce, right? They can sell, right? They, but then the minimum and maximum demand for E1 and E3, you can find out that 5 units and 10 units. And that's indicating minimum and maximum, right? So these are respectively. So therefore, E1, it is the minimum, right, of 5, and E3, maximum of 10. So that means like if you are producing the E1, then it has to be 5, right? So otherwise, you should not produce it, right? So it's 5 or anything above 5, right? And then the E3 maximum you can produce is 10. So therefore, you can see X1 has to be greater than 5 and X3 less than equal to 10. And so we can find out that additional constraints like that. So and then like the here that like all of them are right, X1, X2 and X3 also, right? Now all three of them are positive integers, right? So we know that the integer restriction has to be there as well, right? So if we collect that entire information here, so we can have that entire information here. So we want to find out the maximum combination that maximizes it, right? So that's we are going to find the maximization of the profit. So then I can have this information there, and then I need to identify that. So I can define these three cells, right? So I can define that these three cells as X1, X2, and X3. So, so the objective cells that we need to find out the values, and then my profit values are there, right? And then these are the numbers I need over here. The so and then of course in terms of X1, right? So we need that minimum count, right? So that is X1 is 1 here, and here it is 1 here, and so it's in terms of the market count, right? So we have these two restrictions there. So the then I can go to the others. So basically, like I can put these as zeros here, right? And then I can see that like I can take this cell here, and I can use that our sum product command here. by taking this cell here and the profits, these three cells here. So that's my objective function. And then I can find the constraints here. So the product of these cells here, multiply with this one, and I can make them fixed. And I can pull this down, all of these. So that's basically I'm multiplying them, right? And I'm having uh, the constraints defined like that. Okay. So that's basically the setup that we need for the entire problem, right? And then I can define into the our solver package here. So I can define this cell here as my objective cell, and I'm doing the maximization and changing the variable cells, these three. And then I can add the constraints here. So first one is this one is less than or equal to 80. And this one is from equal to 80. This one less than equal to 50. Give me a second. This one. So those are my constraints, and give me a second. Okay, right. So those are the my constraints that I'm going to have here. So and then like now, of course, now we can run this one like this and see what are the solutions we are getting, and we are without putting that our integer solution, right? So I can go with either simplex or whatever, that it doesn't matter that much, right? So and I'm doing the maximization. So let's try to go with this one and see. It's already giving me the values as 5, 15, and 10, right? So that means like the in general that the we don't need to worry too much about putting them as integers, but practically so they can have any the decimal like numbers here as well. Let me just try to change one of these. Okay, so I had to keep the solution. So say something like, let me try this as 3.5. Yeah, now you can see it is going up to 16.25. And then now, if you're thinking about this producing the items, then they cannot be integers. They need decimal numbers. They has to be integers, right? So that's why I need to put that additional constraint. So I can add that additional constraint as the I can select them and say that they are integers. And then so when I solve it, so then I can see I'm getting 5, 16, and 10, right? So that's the indication of that maximum I can get is 139 profit. And then how many items you have to produce from each the item. And so we can identify uh, that particular setup like that. So, so that is this example here. And any questions or like, I hope you guys can identify this, right? Uh, Give me a second. Okay, so before moving on to the next question, right? Any doubts regarding this calculation, or are you guys okay with this particular calculation? Any other uh, thing that any other constraint or any other question or anything that you have? So in general, of course, so that's how we can work on these calculations. Or just did some correction here, right? So this to make it an decimal number, right? So so those are the some applications you can see, and then in general you can see that like, so now if you look at the all the resources availability now, you can see they are not perfectly used, right? So the in terms of some resources you can see they are kind of like the having some idle situation, right? So in the some resources may not be used that much, right? It's only 120 out of 180, right? So that means polishing resources are kind of like too much, right? So you can notice that they might not used that much. And finishing also, we are using only 39 hours, right? So that's again having some restriction on that, right? So that's we are not using as much as they are, but basically we are using the grinding, right? So it's up to the total capacity the grinding is using. So that's in general we can identify. So right, so that's how we can work on these uh, in situations. So basically now, as your final conclusion, what you have to say is that so our maximum profit we can get is 139 here, right? And then each production, from E1 produce 5 items, and E2 produce 16 items, and E3 produce 10 items. So that should be our combination that we are looking at. Okay. So so that is this example. And shall we go into this one then? So let's look at this particular uh, example here. So they are the paper manufacturer, right? So they are producing two types of papers, right? So they are named as A and B, something like the 80 GSM and 70 GSM or something like that, right? So they are looking at two types of productions, right? And then the production capacity, right? So they have a limitation of the 400 tons and 300 tons, right? So that's uh, from A 400 tons and from B they are producing only 300 tons, and so that's the restriction, one of the restrictions they have, right? So of course now due to the capacity restriction, that means like the in terms of storages, right? So they are the if you produce more than that, you cannot store them, right? So until you ship them or whatever, right? So you have some restriction like that. So uh, so in terms of like production hours, right? So they have 160 production hours in a week, right? Uh, so then the so in terms of the 160 production hours, right? So require zero point 0.2 hours to produce paper A and zero point 0.4 hours to produce the paper A type B, right? So and then the profits from each one will become the 200 from A and 500 from B. And so that's in terms of the per ton, right? So that's in terms of the tons that you are producing, right? So, and 1 ton of paper type A and B, and they are requiring that 2 and 2.5 the tons of chemicals, and so it's and then zero point 0.5 and then zero point 0.4 tons of raw materials, right? And then the and we have some additional restriction here. And the paper type B production must be less than or equal to the two times the paper the type A production. So that there is some additional restriction like that as well, right? So formulate it as a linear problem, right? And to maximize the profit, and then find the product optimum production mix, right? So let's see that like the in terms of that our restrictions there, right? The how we can apply those restrictions. So now, if you look at that everything like so that up to this point here, the it's basically like the it's the same setup that we had earlier, right? But then the this one is some additional restriction we have, right? So let's see how we can apply that, right? So if you think about the situation, right? So I can define that as the x1 and x2, right? As the number of tons we are producing from A and B, right? So that's the values there, and then our the objective function I can define as the 200 times x1 plus 500 times x2. So that's my objective function, and then I'm doing maximization, and then I have the my constraints, right? So we use that as the subject to the constraints, right? So then like in terms of the production hours, right? So we have that the point 2 uh, hours for the first one and 0.4 hours for the second one, right? So it is 0.2 times x1 and 0.4 times x2, and maximum capacity is 160. So we have that information, right? And then of course we have this the the and then we have that like before going into that, actually we have that the limitation there, right? So that x1, right, the maximum that you can produce from x1 is the 400, and the maximum you can produce from x2 is 300. So we have some additional restriction like that. Each one we cannot go beyond these two values, right? And then the chemical requirement, we have that 2 and 2.5. So chemicals, right? And then 0.5 and 0.4 in terms of the raw materials, right? So I think here that we are missing some information, right? So that I think like if I look at over here, I see that like we have these 1400 and 250. Those two numbers are actually not here. So that's the type of mistake is here, right? So basically like in here I need to add that the chemical maximum chemical availability is the 1400, and then maximum the raw material availability is 250, right? So that we need to add those two numbers there, right? So therefore I can have those two here. So the 1400 and 250, right? So I need to add those two sentences there. And then the in terms of that our the additional constraint that we have, the type B production must be less than or equal to the twice the type A, right? So therefore it's 2, we can identify that has to be less than or equal to the 2 times x1. So that's our the restriction, the additional restriction we can have. And now once you look at this entire setup, so if I just set up this up to this point, it's the same as what we have done earlier. But then now we have to discuss how we deal with this one here, right? How do we identify this additional constraint once we are applying it into the solver, right? So how do we set up this one? So what we need to do is that if you look at this constraint here, so we need to bring all the variables into one side and all the constants into the other side. So if I bring all the variables here, then this is going to be in this side, and I had to put negative. So it is negative 2 times x1 and then plus x2, and it is less than or equal to 0. So I can put that additional constraint like that. And so once I bring everything into one side, right? So I have the additional constraint defined like that. Okay, so that's the additional part that we need to have, right? So once I have this additional part here, right? So now let's try to input that into the question here. So if I look at that information here, so that profits 200 and 500, capacities the 400 and 300, and then the production hours, and then chemical, and then raw materials. That is the requirement, right? So the now, so that's the information we have, right? And if I just apply them into the Excel, the solver there, and so I need to put that the capacity, right? So so that is the capacities are 400 and 300 here, right? So x1 has to be less than or equal to 400, right? So therefore this is 1 and this is 0, right? And then the in terms of x2, that is this is 0 and this is 1. So the x2 is less than or equal to 300, right? And then the production hours and chemical and raw materials, so I can add these three there. So I have those three numbers there. And then in terms of our market count, and so that is the additional restriction that we have. So then I need that I need that in terms of x1 it is -2 and x2 is 1. And right hand side less than or equal to 0, right? So these are the additional constraints that we can have. And then I can go into the solver package there. So, okay, before going to that, actually, I need to set up the sum products here, right? So these are the objective cells here, right? And then I can have the sum product here. Right. So that's how I can set up the sum products there. And then I can go into the solver. So that's my objective cell, and I'm maximizing. And I can add the constraints. So So all these are less than equal, right? Okay, so I just write the all the constraints there. Okay, so I have these, and let's first run them and without saying that they're integers, right? So let's see whether what is the solution we are getting. So anyway, I'm getting that some very nice numbers there, right? So 200 and 300, right? But if you make sure that if you're getting some decimal numbers here, then make sure to include that as the integers, right? So, and the maximum profit, the 190,000. So that's our final conclusion we can have. So the maximum we can provide is we can get is the 190,000, and the production mix you can see X1 200 and X2 300 items. So basically now X1 is kind of like we're not going to produce the entire the amount. And in terms of all the other variables, only these two are matching with the capacity, but others are going to be having much smaller than that. So, so that's how we can work on uh, this example. Uh, any questions or any doubts? Okay, all right. Shall we go to the next one then? So I let you try this one. So try to read on this one and see whether you can identify it. Give me a second. Just read this one first. Okay, so let's look at this example. Uh, so they are having that they have the production of three items A, B, and C. And each product must they pass through three processes, right? The so then uh, each processor has the limited number of the hours available per week, right? So and they have some the raw material labor and the market demand constraints. So so now if you look at that three items here, right? And then these the requirements, right? The so by looking at this capacity here, so let's see that what are things you can identify from here. In terms of like the process, the three stages, right? So number of time required on each stage for each product, right? So that information is given here. And then in terms of the raw material, so this is the requirement, right? And then uh, the labor requirement, the given like that, and the cost requirement is given there. The, so each production costs are given there, right? And then the selling prices are given here, and then the maximum demand available for each item is given there, right? So this is infinity means that this, you can produce this one as much as possible, but this ones has to be restricted to the 800 and 500. So now that is the given information, right? So then you can formulate the problem, right? So you can have the decision variables, the number of items produced by the type A, type B, and type C, right? So this has to be X3. So the and then I can write down to my profit, right? So profit constraint, I can have the profit constraint as the so so each one the so we can identify that now. We have the cost and the selling prices are given there, and so therefore we can calculate the profit, right? So therefore we can have the profit as the 10 minus 5 from the first one, right? And then the 8 minus 6. So these are my profits I have. So 5, 2, and 5, right? So that's how I get the profits. So these are my objective function there. That's going to be my objective function. And then I can define some constraints here, right? And I think like this again now this table actually they are not providing these constraint numbers here, right? So we need these four numbers that's not given there, right? So in terms of the raw material, right? So this has to be 3,600 here, right? And then 3,000. The also these are the over here, right? So it is 3,600, 3,000, and 2,700. So that's those two numbers, right? So that's in terms of the stage one, stage two, and three, and one, two, and three, the available minutes. The and raw materials, that is 600 here. The and labor is 500. And the 805, these two numbers are given there, right? So that's so these numbers has to be there. So and then we can write down the constraints on each one, right? So we have just write down it over here, right? So each constraint less than or equal to these three, and these two are here, and then the individual constraints uh, x2, x3, like that, right? And then I can have my some products here, and so I can put that the demands here, right? And so then I can write down some products here, right? And then now, of course, I can say delete this here, right? So that is the sum product I can have the, and then I can just pull it down to all these cells here. So then all these are less than equal sign, right? And then I can go into the data analysis here. Also, the solver, I go to the data and solver, and this is my objective cell. And variable cells are these three, and I can have the constraints. Now, of course, now we have this option as well, since all these are now in the less than equal sign. I can directly select all these and directly select all these as well. And say, okay, so it's basically now they're adding all these constraints all together like that as well. Okay, so we have that the some additional way like that as well, and you can do it in that case. And then I can go for the solve here. So then I can find out that the optimum numbers are going to be like that, right? But then now again, you can see these are kind of like the decimal numbers here. So that's indicating I have to use the integer restriction there. So I can say these three uh, integers. And then I have this the solution like that. So that's indicating basically now uh, is saying that like only uh, type B has to be produced. So type C has to be produced, right? So not the other two, right? So in general, then that due to the other restrictions here, you can notice that. So production only the type C is enough. right? So that's what they're indicating over here. So, so now practically now whenever you are thinking about these, so you might see that like now by looking into the situation, right? So sometimes these productions, so these availabilities or the use of these raw materials and labor rights is indicating that these other two types are kind of like not up to the standards or whatever, right? So therefore, like may have to change these. You may have to modify these numbers, right? So that way, you will be able to identify that the production of these two is also going to be something useful, right? So we can identify that. Um, so that's this example here. And shall we go to the next one here then? So, right. So I'll let you read this one. So it's a kind of a long one, right? So, so these questions can be like getting the pretty much longer questions, right? Anyway, right? So just we need to identify what are the given information, right? So then based on that we can identify the our restrictions that we can have, right? So so read this one, right? So maybe sometime. Okay, so let's look into this example here. So so they are looking at that the 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 provincial authority of the central province. So they have that like their locations are their offices are kind of like in a much more spread out a region. So basically, they want to bring them to a one place, and so they are looking into a situation like that, right? So 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 they want to bring them into the close by place, and then uh, so that's the idea, right? So they once they bring them together, right? So in terms of that, the the functioning of them, right? So will be going to be much the easy, right? So and they selected like four different places, right? So then of course either you can go to like all the four different places, right, and build like the of course like four buildings, right? These are kind of like in terms of the close by places, right? So we have to think about like that, right? So and then either you can take only three of them or maybe two of them or only one of them, right? So we have that freedom to choose them, right? So but then like of course what happens is like once they go to the different financial institutions and they ask for uh, the the loan the interest rates, right? So the on to the different places, so they are giving different rates. So let's we have to identify that. So they are going to give you the different places, and each place they are going to give the different rates, right? So and because of that, the rates and on different places are the changing, right? And then the and then also like the requirement on each place, the capital requirement also different, right? So different places have the different requirements, right? So so then you can decide on, right, the and then like so one bank will not provide you that all this amount, right? So they're providing some this amount, right? So therefore we have some restriction, right? So based on those requirements, right, you can decide whether to go for all four places, so whether to go for three or two or one, right? So we have to identify what will be the best option. So now in this case, we are doing the cost minimization, right? So this is what we need to do is that they minimize the cost, right? So let's try to identify the situation here. So the so now the next question that we have is that now what are the other the variables that we need to define here, right? So in terms of that identifying the uh, in terms of that going through that uh, the each of these places, right? So we need to see that like whether do we need to go to these places, right? And then the how much from each place that we have to get, right? So now for an example, now if you go to First Capital Bank, right? So whether to go for the Hill Street or Bank Street or whatever, right? And then how much you want to get, right? So we can see that like under the 8% rate, right? So you can get that 60 million that you need uh, from this First Capital, right? So that's one option we have, right? And then you can go to the people's this one, right? And then that's like so this place is they're giving the lower rates, and this place they're giving the highest rates, right? So that's, and we can identify that, and then by doing looking at them, so we can see the what are the uh, so we need to identify from each place, right, how much we can get. So variable that we need to define here is basically now all these altogether like the 12 cells here, right? So we need to define some 12 cells like that, and then each cell is representing a number, right? So that's the each one is indicating that the uh, the whether how much you like to get from each and the financial institution for each place. And so therefore I can define that the x11, x12, x13 and so on, right? So the x11, 12, 13, 14 and so on, right? So altogether 12 variables are there, right? So up to the 3, 4. So that's the amount of that credit that you want to get from each place. So that's the indication of these are the variables that we need to define. And we can see that like these are also integers, right? So we need to define them as integers. So then we can see that our the objective function, right? So what's going to be the objective function that we can define here? Once we're looking at that, all these places here, right? So we need to see that like now if I get that entire money, right? So the using this place, it is the 8 times and so that is the amount of money that you're getting from here. And then this is also 8 times the amount of money you're getting from there, right? And so on, right? So then 10 times and 11 times and so on, right? So by multiplying each of these numbers, right? So you can see what the amount that you are getting from each place. So you have to multiply by them. So you can take this as the interest rate. So that therefore this is 0.08, right? 0.09 and 0.09 and so on, right? So therefore you multiply by that and the based on the amount that you are getting, right? So so that's going to be your total price that you're going to get from each place, right? So I can write down my objective function like that, right? So each number multiply by the x11, x12, x13, x14, and so on. And I'm just multiplying by 0.01 here to indicate that they are interest rates. So that's the final answer will be kind of like the multiplied by the interest rate here. And so therefore, it's kind of like uh, the interest amount that you have to pay, right? So this is going to give you the basically the interest amount that you are going to pay, and you want to minimize that interest rate that you like to pay, right? So that's the indication of that. So even if you don't multiply the 0.01, it doesn't matter, right? So this then just some number that you are having and you want to minimize that number, okay? And then we can define that our the constraints. So what are the constraints we have there? Now in terms of the rows and in terms of the columns. we can define our constraints, right? So then uh, if you are, it doesn't matter like whether you are taking from this place or whether you're taking from this place, right? So then the uh, whatever the amount you are getting, this is x11, x12, x13, and x14. So that total must be less than 80. And then summation of this total. So that's like without worrying about the interest rate, the total amount that you're getting here, right? So that's less than 80, and this is less than 100 and 120. And similarly, in terms of the columns, right? So the column summations, so that is the capacity that you need to build in this place, right? So therefore, you can take that entire amount from one place, or you can split it out, right? So then that summation has to be less than equal to these numbers. So those are our restrictions that we have, right? And then also like all of these has to be integers, right? Now with that, our requirement, right? So I can draw that the table like this here, right? So these are the amounts of the interest rates I have, right? And then these are the the objective cells that I define, right? So I just put them as x11, x12, and so on, just to indicate that the what is this cell is representing, right? And in terms of these variables I have there, right? So the and then I'm defining that these cells here. So these are my basically like the presenting these variable cells I'm having, right? And then my capacities are there, right? 80, 100, and 120, and this capacities here, right? And then I can take my uh, the variables cells here, right? So these are the summations, and I can take the summations, right? So that summation of each row, right? So that's my representing these summations here, right? And then the one more thing here is that now the in terms of that summations here, right? So I need to put the equal sign here. So what happens is like now in terms of these numbers here, right? So what we need is exactly these amounts. Or we can say that it is bigger than or equal to these numbers. And remember that we are doing a minimization here, right? So this is a minimization, right? So therefore, either we can go for these numbers or anything above these numbers. So for to build this the Hill Street place, right? So we need 60, but if you're getting anything larger than that, that's also fine, right? But we need exactly that amount, right? So we don't need anything other than that. So we can say it is equal, right? And then similarly, the here that in terms of that the in terms of each institution, right? They are going to provide only these numbers. So you cannot go beyond these numbers, right? So you have restriction here to have each one of these to be less than. Okay, so we can go with that those restrictions like that, and then finally my objective function will become the sum product of the this set of numbers here and this set of numbers here, right? And then finally I multiply by 0.01 as well, right? So that's the my setup of this problem, right? And let's go to this solver. So this is my objective cell. And now make sure that I'm doing the minimization here. And by changing the cells, the set of cells here, and I can add the constraints. Now I have to be careful on these constraints, right? So now first one is this one here, and it's less than or equal to 80. And this one less than or equal to 120. And this one 120. Okay. And then these constraints here. So this is equal to this guy. This is equal to this one. So I will just take those constraints here. Okay, so I'll take those as the constraints. And then like now I will just leave it as the without saying integers, and let's see what are the solutions they're going to give. So even without saying the integers, they're giving me the integer solution here, right? So therefore, I don't need to especially mention them as the integers. But so with that, we can identify the solution there. So, and you can see that these are exactly matching, right? And then of course now in this case, these are also exactly matching, right? So, and then the total interest that we are paying is 28.3. So basically now, first two cases, you can see you can go to each bank, right? And then the other two cases we are splitting out, right? So now in this case now, the I think now when we read the question, I think I mentioned that like we can select either we go for the all four places or different places, but what it says is that now we are saying that like we have to go for the all four places, and so we decide to go for all four places. But thing is that now the each bank is providing different rates, so that's why we need to find out that what are the best the rates we can have from each bank, right? So therefore, based on that, now we are using these rates 9 and 8, and then 10 and 10, right? And then 10 and 9. So those are the minimum rates that we have, right? So that's the idea of how we can solve it. So now it is 4:15, right? So these are like the questions. I can bring one more question. Like, give me a second. I will open. I'll stop the sharing, right? And I will open another question. Give me 1 minute. Okay, so uh, let's do one more question, right? So in terms of the our the linear programming questions, right? So let's look at this, the question number 16 here, right? So this is the some questions we have, right? So from your actually the other lecturer, right? So uh, yeah, I will just I will share you this one, right? So I will provide you this question as well, right? The So they are looking at that garment factory, right? So they have the five tailors and then the five different types of garments, right? So they are in the situation like that. The so all the like the all the five tailors are capable of the making the all five types of garments, right? But then what happens is that uh, the each one, right? So the now this is kind of like now they are giving us the profit here, right? But then in general, of course, now when you think about like different people are making the different garments, so that the amount of time they are getting, right? So it's kind of like the variable, right? So each one will take different time, right? So then like if you calculate that time into the profit, then you can identify the profits like that. So we can do the same thing by taking the time required as well, right? So then it's going to be the minimization problem. But if you take it as a profit, then it is a maximization problem, right? So it's like you can look at the situation in two different ways as well, right? So then the question is that now these are the profits given there, right, for each type of the garment, right? And then the each tailor, right? The So that the profit you can make by producing one item, right? So by the each tailor, right? So we can see that like now if you take the tailor one is making more profit by taking the type two, right? And then tailor two it is again type two, right? But then the requirement is that uh, and um, the okay, so I was trying to check that like this. So we can look at that number two separately, right? So if you look at the number one, right? So, mm, so these are like the profits are given here, right? So for each one, right? The actually the now the we can think of the situation. I was like initially thinking about it in a different way. Actually, the okay. So these are the like the uh, these are the questions, right? So, yeah. The mm, Okay, so initially now so basically like now we don't need to produce that all five types, right? I was checking that like whether we need to produce that all five types or not, right? So basically like we don't need to worry about that production of all five types, but we just want to see that like so these are the profits we can get from the by the each tailor, or like we can think of like, let me see whether that is given as the mm, yeah, did not check this actually. He was taking this as the he's multiplying by profit trend. Some wording of that question is some doubts actually. I was checking that actually. Um, by checking on this solution here, it is kind of like a different thing. So anyway, like so just like I had to double check on the wording of this question here, right? So uh, so these are like these numbers we can think of like uh, the each tailor how much they can provide, right? And then uh, so each item will give you the profit of two. So therefore, total profit you can get from this tailor one is the 2 times 7, right? So we can think of like the total profits going to be the multiplication of them. So that's what you can find over here, right? So the total profits you can find out like that. Okay. So we multiply that each number by the uh, each column here, right? So and then uh, the so then like now we have to decide that now each tailor can produce only one type. So that information is missing here, and so I need to find out the correct the wording here, right? So that wording is missing here, right? So each tailor can produce only one type, and then the two tailors will not provide the same type. So we have some restriction like that, right? So so then like the so we need to worry about that the those that type of a restriction, right? So that if all the types has to be produced, and then one tailor is going to give the only one type, right? So if we have some additional restriction like that, right? So so let me write down that, right? So so we have the profits given down. So this is fixed off. So give me a second. So this is switched off. So, so we'll assume that like the each one is given, each type has to be given to one tailor, right? So therefore, and all five of them has to be produced, right? So with that in mind, if you think about that, so I can make these cells as my objective cells there. And then the important thing we have to think about in this case is that now when you think about these the variables there, right? So if I define them as the x11, x12, and so on, right? So I'm defining some variables, but then that variable is not representing whether like how many amount that we are producing, but that variable is just producing whether you are providing that particular type into that particular tailor or not. And so you are giving some the kind of like the in terms of like some that you can call it as some kind of a decision that you are making, right? So they to give it to that person or not. So that's kind of like a decision means that one or zero, right? So we are in a situation like that. So okay. So that is the idea that we are looking at in here. So we are thinking of like kind of like a decision making here, right? So it is like the not the whether to go for that one the and then like previously what we have is that like if you look at that particular type, then we are deciding how many items that we are producing from that type. But in this case, we are not thinking about like that. So this is kind of like they are producing this amount of items, right? And then each one will give you the profit like that. So then this is the profit that we are going to have. So what we want to do is like we want to maximize the profit, right? But then we have some the important decision to make whether to give it like the type 1 to the tailor 1, then this has to be 1 here, right? And otherwise it is 0. So therefore like this is kind of like we are defining like a special type of variables and we call them as the decision variables. So now the in terms of like our identifying the variables, earlier we identified that so we can have some real number variables as well as the integer variables, right? So sometimes they can be like just the complete numbers, right? And then the other option we have is they can define as the binary variables. So that they can take only one decision, either to go for that one or not. So that's the binary decision that we are going to make. So give me a sec. Right, now it is there. Yes. So now I can define that this. So this is the additional part that we are having in this example here. right? So we are introducing these decision variables. So we can call them as the binary variables. So that means like, so they are taking only the values 1 and 0. Binary means that like, so they are taking only values 1 and 0, right? So 1 means that we are saying that as the yes, and 0 means that we are saying the decision as no, right? Yes or no situation, right? So that's, now I can define some binary variables here, right, for each column, right? So basically I have these the x11, x12 up to x15, to 1, to 2 up to x25, and then x51, x55. And so I have that the bunch of the binary variables defined like that, right? So I have all these bunch of variables, right? So then the our objective is what? So we want to decide that the out of these binary variables, some of them will be 1 and some of them will be 0, right? And my objective is to pick up the best numbers from here and put 1 to them and then 0 to the others. So therefore, basically I want to represent that each and every cell here, right? So I'm defining that altogether like 25 binary variables like that. And then I can multiply each one by this, the number, right? And then that's my the sum product I can have from there, right? So the from B10 up to F14, right? And then I5 up to M9, right? So that's the product of all these. So that's my objective function. So then like without any constraints, it's basically like all of them has to be 1, right? But we know that we have some restrictions. So in terms of the rows, only one of them has to be 1, right? And then in terms of columns, only one of them has to be 1. So that means the summation of these, right? If two of them becomes 1, then summation becomes 2. So therefore, only one of them will be 1. That means I can take their summation, right? And then summation has to be equal to 1. So this is exactly equal to 1, right? And this is also, all these summations has to be equal to 1. And similarly, in columns also, I can take their summations and they are equal to 1, right? So that's the idea of that, like the this type of variables we can define here, right? So then now the additional thing is that I have to make sure that these are binary, right? So now we can see that like in terms of that here, right? The once you are going for the constraints here, you can see I have this bin command here. So that's for the binary, right? So I will come to that, right? So with this information, right? So I can have my objective cell is this one, and I'm doing the maximization on this one, right? And my variable cells here, right? So the variable cells are going to be this set here, okay? And then I can add the constraints here. The so I can say that I can have this set here and say that they are equal to this set here, right? That's one constraint I can have. And then I can take this set here and then they are equal to this one here. Okay, so that's my constraint that I defined. And then the additional thing I have to define, that is the take these cells here and then say they are binary. Okay, so I can define that information there, and I can use whatever the technique here, right? So it doesn't matter. So I can say, okay, so now I get the solution, right? So I can say, okay. So then I can see that each row I'm getting a 1, and each column I'm getting a 1. So that's indicating we are assigning that each type into the uh, each type assignment to the each tailor. And so that's the idea that we can see. So the maximum profit we can get is the 128. So that's how we can identify that, how we can deal with these the binary variables as well. So that's like the additional type of variables we can have, this binary variables or the decision variables. So these are like, now the important thing is that you have to identify that. We need to make a decision there, right? So now if you look at this question here now, in terms of wording here, right? The the what type of so this is the maximize the profit, right? Now this wording is not that much clear, right? I need to change it actually, right? So I will provide you the correct wording on here, right? So then like we have some additional question here, right? So if the tailor D is absent, like D means that I think tailor 4, right? So um, so then like now the question is that the tailor 4 might be absent for a certain time period, right? So now we need more information on here, right? So that's like now we cannot like do any calculation with that information, right? So now what is that specified time period and so on, right? So during that week, so they might have some the others the taking leave or whatever, right? So then like the based on that so that tailor 4, now if you think about the solution here, so the tailor 4 is assigned to the type 5, right? So we can think about uh, the type 5, right? So that means they are getting profit of producing 10 units here, right? So then the uh, basically that if the this one is absent, then these numbers has to be changing, right? So then you have to find out that additional information and change these numbers there, right? So then once you modify that, then your solution will change, right? So you need to do some modifications there, right? So okay, so that's kind of like the other questions you can have. Of course, you can try these other questions as well. So these are the like, so this is again a similar type of question. I will provide you all these questions, and so this is in terms of cost, and so you can minimize the cost on that, right? So that's a similar type of question, right? So these dashes are indicating that this is kind of like very high cost is there. So therefore that is not possible, right? So this is indicating high cost, right? So same type of question. So these again the same type of question. So you can work on these lines. There are like the different. So these are the question that we have already discussed, right? So you can work on other questions here. So there are like several other questions here. So I'll provide you all this, right? So with that, then like now it is 4:45, and so I will stop it for the today then. Uh, so the so I can maybe like I can take one or two more questions from here and discuss few other variations we can have there, right? So in terms of the linear programming, right? So to discuss about the few more variations, right? So and then the next time I can start on the decision analysis as well. And so I want to uh, discuss about that topic as well, the decision analysis. Okay, so the next time I will start about that the topic, and then of course uh, please inform me about that the regarding the extra class, right? What is the suitable date for you, right? And then please inform me, one of you. And if you have already discussed, you can inform me now, or if you're not, you can let me know later, right? So, I'm available on that the next week, the week starting from the 23rd, right? So on 25th, I can do additional class at night, or then the March 4th, or I can do one of those 2 days, right? Or even 11th, right? So you said your class is, the exam is on 15th, right? So then those 3 days, one of those 3 days I can do extra class, right? So let me know what's the availability, right? So any questions? Okay, then I will stop it for the today. See you guys next week.